Hi, Miss Camilla's friends. Today we will continue working on solving problems, but we will extend our knowledge of the strategies that you already are familiar with when working with 3-digit numbers in math. At the end of this lesson, you will have some problems to solve on your very own. I suggest that you use a piece of paper and follow along with me during this lesson so that at the end, when you have your own problems to solve, you will do it all on your own and it will be a breeze. Remember, after this video, there will be a slide for you to submit an assignment directly to me. Then, when you finish it, I'll be able to go over it and make sure that we are doing everything we need to get ready for 3rd grade. Are you ready to begin?
Let's begin with our number routine. We're working again on money, so let's read the problem. At the school book fair, Haley bought a bookmark for 37 cents and an eraser for 25 cents. If she paid for the items with 3/4, what coins did she get back? Pause the recording while you think about the problem and try to solve it. Write down your answers on your paper so you can check to see that if you have them correct when we come back together. Did you realize that this was a two-part problem? Haley bought a bookmark for 37 cents and an eraser for 25 cents, so we need to see how much she spent. If she spent 37 cents and she spent another 25 cents, by adding those two together, 7 ones and 5 ones is 12 ones, and 3 tens and 2 tens is 5 tens, or 50. If we add 12 plus 50 together, we get 62 cents. So Haley spent 62 cents. We know that she had 3/4 to start with, and that's a total of 75 cents. So the question was, if she used those 3/4 to buy the eraser and the bookmark, what coins did she get back? Well, again, we have to know how much she got back in order to know what coins she got back. So if we take the 75 cents and subtract the 62 cents that she spent, we know that she got 13 cents back in change. Now, there's several ways we could look at that, of course, but when we give change, we generally give the least number of coins. So in this case, Haley would have gotten back a dime for 10, 11, 12, 13. So Haley would have gotten back a dime and 3 pennies. She might have gotten back 2 nickels and 3 pennies, since 2 nickels makes a dime, or she could have gotten back 13 pennies. But this, what you see here, is the least number of coins that she would have gotten back. Let's take a look at our try it problem for today. Read the problem yourself first, and then try to answer the questions that are at the bottom. When you're ready, pause the recording, and when you're ready, come back and we'll talk about it together. So we never just jump into a problem. It's really important that we do exactly what you just did, which is to think about, what is this problem about? And what is it that what is it that they're asking me to find out? And what do I need to know to be able to answer that information? So let's read the problem together first. There are some adults and some children helping to clean up their city. How many people are helping to clean up the city? Well, as I look at this problem, I think, well, I know that they're talking about cleaning up a city, that there are adults and children working together. And it's asking me to find out how many people are helping to clean up the city. But I don't have enough information because I need to know exactly how many adults and how many children. And right now I don't know that. But now I do. Now I see that that information has been added. So I know I'm going to read this again to make sure I fully understand the problem. There are 254 adults and 328 children helping to clean up their city. How many people are helping to clean up the city? Pause the recording while you solve this problem. Remember that you have virtual tools base 10 blocks available on your Ready Classroom Mathematics dashboard. So if you need to use the base 10 blocks, you can go there and that will help you to solve the problem. If you do use your base 10 blocks, see if you can draw a picture, do a quick drawing of what you did in order to use the base 10 blocks. When you're ready, even if you don't use the base 10 blocks, when you're ready, come back and we'll talk about different strategies that we might have used for this problem. As you solved your problem, you probably realized that you needed to add these two numbers together because we're trying to find out how many children and adults together were cleaning up the city. We know that there's many strategies that we can use to solve a problem. And one of the strategies that you used might have been to use the base 10 blocks that were on your Ready Classroom dashboard. And if you did that, this would be the drawing that you might show to represent the two numbers. If you did not use this strategy, you might say, I don't understand that strategy. Or if you did use this strategy, you might say, I already know this. This is what I did. So as we go through our strategies together, we're going to look at, is this what you did if you used that strategy? Or if you didn't use that strategy, can you make sense of this strategy that somebody else tried? So don't just focus in on what you did. Listen carefully to what others might have done and try to make connections to how you solved it in the same way, even if you used a different representation. So for this drawing here, we see 254 broken into our base 10 blocks, knowing that the big squares represent 100 and the sticks represent 10 for each stick, and the green ones represent a group of one, just one, single. So I see 254 broken down as 2 groups of 100, 5 groups of 10, and 4 ones. And I see 328 broken down as 3 groups of 100, 2 tens, and 8 ones. And that's the information that we'll use for this strategy to solve the problem. Now that you have your groupings, you can add the places together as you see here. Notice there are 500s, seven tens, and 12 ones. If we add that together, we know that 500s is 500, 7 tens is 70, and 12 ones is 12. We have to be careful to be sure to add the same groups of numbers together. The hundreds are added together, the tens are added together, and the ones are added together. When we look at the number 12, we see that 12 is made of 2 groups of ones and 1 10. So the 110 is grouped with the 7 tens. And when we add this together, we have 582. Or another strategy that you might have used would be to break apart the addends, and we call that expanded form. You can see here that as we broke apart 254, we have two groups of 100 or 200 plus 50, which is our 5 tens, plus 4 more ones. Three groups of 100, 300 plus 20 plus 8. A minute ago, we just looked at a different strategy. We used the base 10 blocks. So my question is, how do these two strategies compare to each other? Pause the recording while you think about that. So as you looked at these two problems, these two different strategies, did you notice that in the first strategy, when we broke it apart in expanded form, we would add together our hundreds? We can do that same thing with our base 10 blocks. Count them up and find out we have 5 groups of 100, which is 500. We can do the same thing with our tens place, which is to add our 50 plus our 20 to get 70. And that's the same thing that we would do if we would group together all of our tens, or our rods. And then finally, we can put our ones together, and we would do the same thing with our base 10 blocks. So that when we add this problem in the breaking apart the addends in expanded form, we would add 500, 200 plus 300 is 500, plus our 70 plus our 12, and we would still get 582 people. The last strategy that we're going to look at is using the open number line to add. An open number line is a great tool because it's good for counting on or for counting back. So when we looked at our problem today, we had 254 adults, and that's where we started on our number line. You know that on a number line you can start with either number, but we're going to start with the first problem that's listed on our problem. So as we looked, on our number line we put 254, and then as we went to the next number, 328 is broken up into 300 plus 20 plus 8, and we're going to jump in those chunks. So for the first jump, we're going to start 254, and we're going to jump 3 groups of 100 or 300, and that means we're going to add 300 more, and that takes us to 554. The next time we jump, we're going to jump 20. So we're going to add 20, and that's going to take us to 574. And then finally, we're going to add 8. And where is that going to take us is the question. So if I had a number line that started at 574, which is where I am right now on the one at the top, and I wanted to add 8, how would I do that? I want you to pause the recording and draw the number line that I just drew and show how would you add 8 more, where would it take you, and what would that look like? Come back when you're ready. Okay, so I want to add 8, and I could just count by ones. I could say 1, 2, 3, 4, 5, 6, 7, 8. I would land right there. I'm not sure yet what that is, but I would land right there at that spot. And every time I jumped, I was adding 1 because I was counting by ones. So So I made a total of 8 one-count jumps. Wonder where I landed. Or I could have said, I'm going to start at 574. But instead of making one big jump of 8, because I'm not quite sure where that will take me, I do know that 8 can be decomposed into 2 parts. I could have 7 plus 1, 6 plus 2, 5 plus 3, 4 plus 4. Any of those would make 8 if I broke 8 into 2 parts. So I also know that when I want to jump in big chunks, it's easy for me to go to friendly numbers. Friendly numbers are usually numbers that end with a 0, such as 10 or 100. So I could be counting 10, 20, 30, 40, counts of 10, or 100, 200, 300, counts of 100. Sometimes people count by friendly numbers of 5s or 25s, but for this we're going to be thinking mostly about counting by 10s or 100s. So I'm at 574 and I want to go to the next most friendly number, which is pretty close, and that would be 580. Oops, 580. So I'm going to make a big jump from 574 to 580. Now that is a jump of 6, and I know that because 4 plus 6 gives me a 10, which is my next number from 74 to 80. 80 is my next group of 10. If I look over here, I just used the 6. So if I jump 2 more, I will have jumped 8. 6 plus 2 is 8, and that will take me to 582. So if I counted up above by ones, it took me to 582 people.
So today you have learned how to apply addition strategies that you already know to solving problems using 3-digit numbers. Remember that you can always go back and watch this video at any time to look again at the different strategies. Your last task for today is to fill out and submit your assignment on the next slide. You will solve 3 problems. I listed them here if you would like to review them before you begin. Notice that it says to use a strategy we talked about today in the lesson to solve the 2 problems. If you're up for the challenge, try to use 2 different strategies for each problem. Also, notice that number 3, there are 2 parts. When you finish, hit submit and I will get it. Have a wonderful day.